Okay, tonight is a lesson on 6-6, solving systems of linear inequalities. And you were given this worksheet in class today, so I'd like you to get this out. And we're going to use this kind of to introduce the concept. A system of linear inequalities, as you notice from number 1, looks really similar to a system of linear equalities. We still have this system bracket here, which means that we're looking for something that will make both inequalities true at the same time. And the difference, though, is that there's not equal signs, there's some sort of inequality symbol. So to start out, we want to remember that we're looking for ordered pairs that will make both situations true at the same time. So for number 1, to decide if this is a system, you've got to substitute 4 and 5 into x and y into both of these inequalities. So if y is 5 and x is 4, 4 plus 2 is 6. Is 6 greater than or equal to 5? Yes. So it makes that inequality true. We do the same substitution when y is 5 and x is 4. 4 minus 1 is 3. Is 5 greater than or equal to 3? Yes. So since this ordered pair, when substituted into both inequalities, is true for both, we would say yes, it is a solution. Okay, so I'd like you to pause the video for just a minute and do number 2, and then restart it when you're done. Okay, now we're going to go on to graphing to find the solutions. And as you can probably imagine, since we're now talking about graphing an inequality, remember that when we graph an inequality, our solution isn't just a straight line. Our solution to graphing an inequality is an entire range, an area. So if we're going to do this with 2 different inequalities, so let's say here's our other one, and we have an area here, it should make sense to you that if we're looking at where these 2 half planes intersect, we're going to get a combined area that's going to contain many, many ordered pairs. So our solutions are not going to be just one intersection point. It's really where 2 half planes come together and intersect. So to look at this, we're going to start out by doing the same thing we did before. We're going to look at the boundary line, y equals x plus 1, and we're going to graph this. So this hits the y-intercept at 1, has a slope of 1. So it looks like this. That's our boundary line. I look back to the inequality and says, since it has an equal to portion, I'm going to connect this with a straight line. And then I decide which side I'm going to shade. Well, I want all the values of y that are greater than or equal to this line. So greater than means we're going to shade above the line. So we're looking at all of this area. Again, if I wanted to check a test point, 0, 0, when y is 0 and when x is 0, I get 0 is greater than or equal to 1, which is false. So that just verifies to me that 0, 0 is not in the shaded region. That looks good. So now I'm going to graph my second boundary line, y equals negative 2x. So that has a y-intercept of 0. And the slope is negative 2. So I go down 2 over 1, down 2 over 1, or I can go up 2 and to the left 1, up 2 and to the left 1. So here's my boundary line, looking something like this, and it should be solid because it's got the equal to portion. So I graph that with a solid line. And now I have to decide if I shade above or below the line. So when you're looking at a line like this, it's kind of deceiving which way's above and below. So I'm pretty sure that below will be down here, but I want to be confident in that. I want to pick a test point. Now as you can see, I can't use 0, 0 as my test point because that's right on the line. That's not going to help me decide which goes above or below. So I'm going to pick this point right here. Negative 1, negative 1. So when y is negative 1 and x is negative 1, Negative 2 times negative 1 is 2. Is this true? Yes, it is. So that means my solution set is going to be everything underneath this line. And especially for my messy folks out there, you're going to want to try to find a way to keep yourself organized with this shading. I use 2 different colors so that I can clearly see the region where they both intersect. So our solution is going to be all of this region that is shaded with both inequalities. Okay, now since there's a solid line here and a solid line here, we keep these boundary lines solid. So our solution set is right here. And now you're supposed to give 2 ordered pairs that are solutions. So you just go over here, grab a different color, and you find an ordered pair in the solution set. So negative 3, 0 is a solution. Negative 3, 2 is a solution. And I just picked any 2 points here. Then they want you for part B to pick 2 points that are not in the solution set. So if you look up here, 0, 3 is not in the solution set because it only works for one of the inequalities. It's in one of the regions, this green region, but it's not in the intersecting region. Or this point out here, 3, 0, that's not going to be in the solution set because it's not in the shaded region. Okay? So I'd like you to pause the video, and I would like you to try to graph number 5. Notice that for 5, they're both in slope-intercept form, and you're going to be graphing them with a dotted line because there's not the equal to part. I'd like you to do all of those A and B. Okay, and the last one I want to talk about is number 7. Lou is buying macaroni salad and potato salad for a picnic. Macaroni salad costs $4 per pound. Potato salad costs $2 per pound. Lou would like to buy at least 6 pounds. So at least 6 pounds means we'd want 6, or we'd be happy with more than 6. And he wants to spend no more than 20. So no more than 20 means we want 20 or less. So as you can see, they clearly define the variables, and this is still something that I see many of you struggling with. You jump right into a problem with X and Y, but you really have no idea what X and Y are representing. So we're going to do our system of equations. So we look back here. $4 per pound of macaroni. So if we buy X pounds, it's going to be 4X plus 2Y, and that's representing our cost. So $4 per pound plus $2 per pound, and we don't want to spend any more than $20. It would be okay to spend 20, so that's why we have the equal to, but we want less. And Lou would like to buy at least 6 pounds of salads. So this is our quantity. We want our pounds of macaroni plus our pounds of potato to be at least 6. So it could be greater than or equal to 6. So right away over here on your graph, you want to label your x-axis as macaroni, your y-axis is potato salad. You want to get that down, and you want to start graphing those. So this first one is in standard form, so I'm going to use the cover-up method. When y is 0, 4 times 5 is 20. So 1, 2, 3, 4, 5. So I'm going to go out here to 5, 0. And when x is 0, y is 10. So I'm going to go all the way up here at 10. So I'm going to graph this line with a straight solid line because it's got that equal to portion, and we want everything less than or equal to. The very first time you shade, I would shade really lightly just so that you can get an idea. So we're looking at just this triangular region. Just as a reminder, we're not going into these quadrants here, second, third, or fourth quadrants. because macaroni and potato salad can't be negatives. So now we're going to graph this inequality. So the cover-up method, when y is 0, x is 6. So 6, 0. And when x is 0, y is 6. We get our second line. That's a little bit flatter. It's still a solid line because of the equal to portion. And we're looking now for all the values that are greater than or equal to this line. So everything up here. Now instead of scribbling all over my paper, I want to keep in mind that I'm looking for what region is in both shaded regions. So below this line and above this line, we're looking for that solution set right there. Okay, now we're assuming that you can't buy half of a pound. I'm guessing. I guess it doesn't really say that, so I guess anything in this ordered pair. So some possible solutions. Just picking some easy ones. So you could get 2, 6, which means 2 pounds of macaroni, 6 pounds of potato. You could get 1, 7. Okay, you could get over here. This looks like 3, 1, 2, 3, 4, which is 3 pounds of one, 4 of the other. Okay. Alright, that's it for tonight. Make sure you finish up those 4 book problems that many of you didn't get done in class today, as well as these notes, and we'll work on this tomorrow. Have a good night.